bucka. Ha. You know the deal.
The first thing we're going to talk about when we're talking about probability is what's called possible outcomes. So possible outcomes are the number of things that could happen that are equally likely in what's called a fair experiment. And in a fair experiment, there are things that can happen. And in a fair experiment, those things that can happen are equally likely. In other words, they have the same chance of happening. So, for example, if we're talking about what the weather is going to be like tomorrow and whether or not it's going to rain, well, if we think of those two things that could happen as possible outcomes, well, they're not equally likely. Whether or not it's going to rain depends on a lot of factors, and there's not always an equal chance of rain or no rain. So that would not be a fair experiment, because those outcomes are not equally likely. But if you think of an example like flipping a coin, when you flip a coin, there are two things that could happen. The coin could land on heads or it could land on tails. And those two outcomes are equally likely. You have the same chance of either one of those two outcomes happening. So flipping a coin is an example of a fair experiment. So when you're trying to determine what the possible outcomes are, there's three questions you want to ask yourself. So in an experiment, you want to ask what could happen, and then you want to know, are the things that could happen equally likely? And then if they are equally likely, you want to ask how many are there? And how many are there tells us how many possible outcomes are there. So with the example of flipping a coin, if we flip a coin, there are two things that could happen. We could get heads or tails. And I'm just going to use H and T for that. So we could get heads or we could get tails. Are they equally likely? Well, yes, we have an equal chance of getting heads or tails. So if they are equally likely, we can say that in the experiment of flipping a coin, there are two possible outcomes. So the next example we're going to look at is if we roll a dice, and I'm talking about a six-sided dice that has the numbers 1 to 6 on it. So when we roll a dice, the first question we ask ourselves is what could happen? Well, what could happen is we could get 1, 2, 3, 4, 5, or 6. And when we roll that dice, are those outcomes equally likely? And as long as it's a fair dice, as long as it hasn't been weighted for cheating or something like that, then yes, they are equally likely. So how many possible outcomes do we have here? Well, we have 6 possible outcomes. It could land on 1, it could land on 2, it could land on 3, it could land on 4, it could land on 5, or it could land on 6. So that's how many possible outcomes there are when we roll a dice. So here's another example of an experiment where we have a spinner that we spin that looks like this. And so again, the first question you ask yourself is what could happen if we spin the spinner? And what could happen is we could land on purple, we could land on yellow, we could land on blue, or we could land on green. And are the outcomes equally likely? Yes, they are, because the pieces are the same size. So how many possible outcomes are there? There's 4. So here's another example of a spinner, where again, the first question we're going to ask ourselves is if we spin this spinner, what could happen here? And what could happen here is we could land on purple, we could land on yellow, or we could land on blue. And now when we ask ourselves the question, are these outcomes equally likely? Well, the answer that you're going to get right here is no. This wouldn't be a fair experiment, because as you can see, the blue section is much larger than the purple section or the yellow section. So in this case, for this experiment, we can't say that there are just 3 outcomes, because those outcomes are not equally likely. So if the outcomes aren't equally likely. What we want to try to do first is see if we can make them equally likely. Now, with the example I used, whether or not it's going to rain tomorrow, we can't make that equally likely. But with this experiment, if I want to make the outcomes equally likely here, I want the pieces to be the same size. In order to make the pieces the same size, we have to cut this circle into quarters. And now, when we're talking about the possible outcomes, well, the possible outcomes are, it could be purple, it could be yellow, it could be blue, or it could also be the other blue section. So now that we've broken this circle into 4 sections that are the same size, when we ask ourselves, are the outcomes now equally likely? The answer is yes. And how many outcomes are there? There's 4 possible outcomes. We could get purple, we could get yellow, we could get blue, or we could get blue. And we have to say blue twice because we have to make the pieces the same size in order for this to be a fair experiment. So the examples that we've looked at so far, the experiments have only involved doing one thing. And the next thing we're going to talk about is combining 2 experiments. So suppose we flipped a coin and we spun this spinner at the same time. And we wanted to know what could happen. Well, we know if we flip the coin, we could get heads or tails, and we know that if we spin this spinner, we could get one of those 4 colors. So if we do both at the same time, we have to kind of list the outcomes here that could happen. So we could get heads with purple. We could get tails with purple. Or we could get heads with yellow. Or tails with yellow. We could get heads with blue. Or we could get tails with blue. And finally, we could get heads with green on the spinner, or tails with green. So here, you'll notice I've got all of the colors, purple, yellow, blue, and green. And with each of those colors, we have the possibility of heads or tails. Now, if we look at whether or not these are equally likely, well, with flipping a coin, we have equal chance of getting heads or tails, and with this spinner, we have equal chance of getting any one of those colors. So the answer here is yes, those are equally likely. And how many are there? There are 8 possible outcomes. So let's go back to looking at these experiments as individual experiments again for a second. So when we spin this spinner, now we know that there are 4 possible outcomes. They are equally likely. So that's if we just spin the spinner. When we flip a coin, we know that there are 2 possible outcomes. We could get heads or we could get tails if we just flip the coin. Well, as we just saw, if I am going to spin this spinner and flip this coin, when we combine these 2 experiments, as we just saw, there are 8 possible outcomes. So that's how many possible outcomes there are when we do both. So again, we could get heads with any one of those colors, so that's 4 possible outcomes, or we could get tails with any one of those colors when we do both at the same time. So that's another 4 possible outcomes, altogether 8 possible outcomes. Well, let's look at another example of combining 2 experiments. So suppose we flip a coin and we roll a dice at the same time. So what are the possible things that could happen? Well, we know if we flip a coin, we could get heads or tails. So we flip the coin and we could get heads. With the dice, we could get 1. Or we could get heads on the coin and 2 on the dice. We could get heads and 3, and so on. And I'm going to list them all here. So when you flip a coin and roll a dice at the same time, you ask yourself, well, what could happen? This is what could happen. You could get heads with any one of the 6 numbers, so heads 1, heads 2, heads 3, and so on. Or you could get tails with any one of the 6 numbers. Tails with 1, tails with 2, tails with 3. all the way up to 6. So those are all the possible things that could happen. Are they equally likely? Yes, they're equally likely. If we flip a coin, we have the same chance of getting heads or tails. When we roll a dice, we have the same chance of getting any one of the 6 numbers. So when we do both of these experiments at the same time, any one of these outcomes is equally likely. So what we can see here is that there are 12 possible outcomes here if we flip a coin and roll a dice at the same time. So let's go back to looking at these experiments individually again. So if we just flip a coin, we know that we can get heads or we can get tails. So there are 2 possible outcomes. And now if we roll a dice, we know that we could get 1, 2, 3, 4, 5, or 6. So there are 6 possible outcomes. Well, as we just saw, when we flip a coin and roll a dice, the total number of possible outcomes that we saw were 12. Well, let's look again back at the previous example that I was just talking about, where we combine the 2 experiments, where we flip a coin. And again, when we flip a coin, there's 2 possible outcomes. And when we spin that last spinner, where there were 4 equal sections, there were 4 possible outcomes. And as we saw, when we combine those 2 experiments, so when we flip a coin and spin that spinner, the total outcomes now for this experiment is 8. So if you look at these 2 examples, you're probably starting to realize what happens when we combine 2 experiments. So when we look individually at the number of possible outcomes there are for each experiment and how many outcomes there are in total when we combine those 2 experiments, well, mathematically, if you look for a relationship between those 2 numbers and the total number of outcomes, you can see that we're multiplying it. So when we combine two experiments, as long as they're fair experiments, when we combine the 2, we take the outcomes of one, the outcomes of the other, and multiply those together to get the total number of outcomes for combining those 2 experiments. So let's look at one more example of 2 individual experiments. So suppose we draw a card out of a regular deck of cards. And in a regular deck of cards, we have 52 individual cards. The chances of drawing any one of those cards is equally likely. So when we're asking how many possible outcomes are there if we draw a card out of a deck of cards, there are 52 possible outcomes in that case. And as we've seen before, if we roll a dice, we know there's 6 sides to a dice, so there are 6 possible outcomes that are equally likely if we roll a dice. Well, suppose we draw a card and roll a dice. Well, as we saw with the previous 2 examples, when we take 2 fair experiments and combine them, so if we draw a card and roll a dice, we have to take the possible outcomes of one experiment, the possible outcomes of the other experiment, and multiply them together. So to figure out how many possible outcomes are there if we draw a card and we roll a dice, we have to multiply 52 times 6, which is 312. So that's how many possible outcomes. Now, I'm not going to list them all here, but for example, one possible outcome is we could draw the Jack of Diamonds and roll a 3. That's one possible outcome out of 312 possible outcomes. So again, when we're combining 2 experiments to figure out how many outcomes there are for both combined together, we take the possible outcomes of one, the possible outcomes of the other, and we multiply them together. So to finish off our lesson on possible outcomes, I'm going to ask you to answer a couple of questions here. So for question number 1, for each of the 3 experiments, do 3 things there. So state what the possible outcomes are, answer whether or not they're equally likely, and then state how many are there. So for the first one, if you spin that spinner, the second one, if you draw a poker chip that's in a bag that just has 1 blue chip, 1 red chip, and 1 white chip. And then the third one, draw a poker chip from a bag that has 2 blue chips, 5 red chips, and 6 white chips. Now, with that last one, it's pretty obvious that's not a fair experiment. Try to figure out how you can make it a fair experiment. How many possible outcomes you would have to say there are in order for that to be a fair experiment. For question number 2, just state how many possible outcomes are there if you combine these two experiments. So if you flip a coin and draw a card from a deck of cards, and remember there's 52 cards in a deck of cards. And for the second one, if you draw a card, look at what that card is, put it back, and then draw another card. So the question there is how many total combinations of possible cards could there be if you combine those two experiments? If you're able to answer those questions, congratulations, you now have a firm understanding of possible outcomes.